Hi, everyone. Welcome to Productive C#. Today, I have a very special guest here with me, Oren. And you probably know him for, he's the creator of RavenDB and a lot of other cool stuff in the .NET space. So I'm going to spend some time with him, getting to know him a little bit better, asking about RavenDB and any career advices that he can have for you. So yeah, let's give it a start. So do you want to introduce yourself, Oren?
Yes, my name is Oren Eini. I have been working in the Microsoft platform for 25 years now. I've been working in .NET and C# since 2001, which makes me feel very old at this point. So pretty much since the alpha or beta release of .NET. I've been very involved in the open source community in .NET platform. I've been Microsoft MVP since 2007 or thereabout. I currently am the founder of a project called RavenDB, which is a non-relational database that is built using C#. And that's about it. I also have a blog that I actively maintain at Ayende.com.
Yeah, I have to say, like, your blog has been a companion of me for quite some time, and you are incredibly consistent in producing posts. I still remember when I joined it on that community back in, was 2007. Yeah, I remember like a lot of discussion about RenoMox and all the amazing blog posts you were doing. So yeah, you're definitely very well known even in Italy, like where I'm from. So first of all, yeah, thank you very much for being wanting to share with us, about your story. So as our audience is mostly made of the .NET developers or people around the .NET ecosystem, I'm quite interested to understand a little bit better what RavenDB can do for me. So obviously, if I decide to use a NoSQL database for my applications, why should I choose RavenDB? So, and what's special about it? I'm very interested to know about this.
Okay, so let's start from the very basic. Why would I want to use an relational database? Relational databases has been the bread and butter of data for decades, since the early 80s, they want the database builds. The problem is that the kind of applications that we build today tend to be incredibly complex. Can you give me an example of an application and significant application that you worked on recently? What type it was, what industry, those sort of things?
Yeah, I'm working for a gay software, so I mostly build like database tooling.
Okay.
Database tooling.
So I'm actually I want to talk about business applications. So let's talk about the ubiquitous example, the online shop.
E-commerce, yeah.
Yes, and I have a shopping cart. And at first glance, a shopping cart looks like a very trivial thing to do. You have the list of items per customer, that's about it. But then you realize that on the back end, there is quite a lot of information that you want to keep track of. The age of the shopping cart, when each item was added, what items were added together, whatever we can apply all sort of promotional materials. He has a plus membership, so we give him this discount, but so this coupon and a whole bunch of other crap like that. And once you actually sit down and look at the full requirements for a shopping cart, you realize that you end up with 8 or 10 tables. And when you want to convert it to an order, well, now you have taxes and payments because they pay using true credit card and a gift card. You have the discounts, points applied to your membership, and now you have another 17 tables. And now you want to do something as outrageous as show me my recent orders page. And the amount of complexity that you have to deal with is enormous. Now, if you are a full stack developer, if you're a backend developer, you want to give me all of the orders from the database. So you do that. And if you use a relational database, you have one of three things happen. First of all, you may actually sit down and properly get your data, in which case you're going to spend a tremendous amount of time and effort on optimizing the way that data is accessed in the system. Or you can say, I'm going to use Entity Framework and let it handle that. And behind the scenes, there's going to be a select n+1. So there's going to be hundreds, if not thousands, of queries being issued behind the scene. Or you can try to say, okay, I will just limit what I'm showing to the user. And previously, when we were talking about applications that were built in the 90s, limit what you see to the user was perfectly fine because you literally had no real estate on the screen to show things. But now, even on a phone, you have to show a lot of information to the user. So just that here is an incredible issue. The other side is what happened when you start working in the cloud, in distributed systems, and now you have to take into account that, oh, this can fail. How do I handle that? Now, relational database has a solution for that, but they tend to be really awkward and complex to work with. And I used to be, for a very long time, focused on database performance. I was a part of a project called Hibernate. It's an object relational mapper, and I would go from one customer to the next and fix the database issues. And they were smart people, and they did their best, and they made a mess of things. And eventually I said, I had enough of that. I want to create something that works well. So I looked into other databases because the problem wasn't with the people or the tools. The problem was with the interaction model with the database. So I decided to look into other things, into non-relational databases, and I looked into document database, and it clicked. It clicked because the shopping cart is now a document, which can be arbitrarily complex. And it also matches very closely the shape that you model your entities in memory to how they're actually stored in the backend. And suddenly a lot of the impedance mismatch, this need to translate between the persistent model and the in-memory model just went away. And if you take it further, then okay, I still want, so at the time there were other non-relational databases around, and I looked into them and says, okay, they're great. I like the concept, but the execution is horrible. No transaction, a lot of complexities and things like that. One of the things that I think is most important about the Microsoft community is the notion that in many respects, you have an expectation of polish. If I'm using a certain system, I want that system to be complete, to be relevant for me. And that's something that all of those other things, oh, here is this 19-step setup to set things up on development environment. And for production, here is this 50-page document that you have to understand and follow, and things of this nature. So I decided to go and create RavenDB, which is non-relational document base. And one of the things that I decided to do is that I want to look at this building of the database, not from the perspective of the DBA, but not from the perspective of someone who builds databases for a living. I want to look into that from the perspective of someone who is using that, from the experience of going to one customer after another and seeing all of the places where they mess up. For example, every single DBA has a story how they added an index to a system and a query went from taking multiple minutes to taking, every single DBA. Redgate specifically exists solely because of a situation like that. And it's not the only company that does that.
All the complexity around the relational database.
So the idea here was to say, okay, what if I could be smart about it? The reason why an index is important in those cases is that otherwise you have to scan the data, which works great if you're running on developer machine
single user, limited amount of data, perfect. When you run on production, it kills you. So instead, with RavenDB, when it accepts the query, it's looked at the query, and then it says, do I have an index for that? And if I don't have an index for that, it will go ahead and create one. And it is smart enough to look at the set of indexes that you have and the queries that you want and produce the optimal set of indexes for your scenario. Now, if you hear, oh, let's go ahead and create a new index in production, from the perspective of the DBA, of someone who is familiar with relational databases, you never do that. That's scary. That's crazy talk. But practically speaking, when you come into building this database engine from scratch, those are the sort of, okay, I just have to do that. So now I have the ability to create indexes on the fly in production safely in an operational manner, which drive the query optimizer to generate the appropriate indexes. And suddenly this huge hill that I got about how do I optimize the application in production is just gone. There are other issues there that matter. For example, let's say that I want to show you the shopping cart. So I have a list of items in the shopping cart, but the structure is, okay, here is the user ID and the product ID and the quantity. If I want to show you what is the name of the product, I have to do a join to another location. But if I have to do join to multiple locations, that leads to a Cartesian product. Alternatively, I can just load it after the fact, but then I'm saying select star from shopping carts for user ID equal X. And then for each one of the products, select star from product where ID equal 1, equal 2, equal 3, etc. So that is an explosion in the number of queries that you're making. Another aspect that we have to take into account is that we are now living in an era of the cloud, which means that in almost all cases, the database is going to be remote, which means that every single query that you run is going to be across the network, which means that you have to pay all of the latency involved in that, which is insane. Now, with Raven, we have the ability to say, oh, I'm going to get this data, and I'm going to immediately need to fetch this additional data. Bring it with me anyway. So this is similar if from front-end developers may be familiar with the ability to give the browser hints. Oh, I'm going to need this, I'm going to fetch that, stuff like that, like HTTP2 and pushing resources to the client. This is taking that into the database layer. And that means that you have one query to the database. Don't suffer from Cartesian product, and you're able to get all the data that you want. Another good example is, let's take what is probably the most basic scenario. I want to show you a list of items, but that list may be long. So I want to show you a list using a page. And in order to show you the paging outline, page 1 to page 29, whatever, then I have to know how many items there are in this query. So here is how you do that in a relational database. Select top n from blah, 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 very complex query, blah, blah, blah. Get me the first page. And then run the same query again, but now the result is a count. So here's what actually happens on the database engine. It has to run a potentially very expensive query twice. Each time it has to do its own network round trip. Utterly insane costs associated with that. And with Raven, we just say, hey, as part of executing the query, I have to figure out how many items I have anyway. So I'm just going to send you that results back, and you can do whatever you want with that. And in typical cases, you just have, again, single round trip to handle that. Now, so far, I just talked about the database engine and the network because that was what was important when I created that. But remember, I spent years working on object relational mapper. So the interface that you get as a .NET developer is extremely similar to what you get when you use Entity Framework, for example. So you have the ability to work with plain old C# objects. They get persistent, serialized, but they can be complex objects. You can have a user class that has a list of phone numbers. And you don't need to have the complexity of how do I map that into multiple locations, multiple tables, because it's just single one document in the database. We also support things like a link, so strongly typed queries. You have identity map and unit of work. RavenDB is transactional, which means that the whole thing can work for environments where you actually need the consistency and reliability that you get from that. Another important aspect is that when we thought about RavenDB, one of the primary goals that we had was that I don't want to need to have a full-time DBA. So you set up RavenDB, and then for the most part, it does the right thing. For example, RavenDB running in a distributed mode takes about 3 minutes to set up, because it's literally give me the URL of the other nodes, and then you're done. And then it create this mesh of interconnected nodes and create a cluster. And you have automatic replication within this cluster. And if a node goes down, then the cluster detects that and reroute all of the requests. The clients do that as well. So you don't really have to think about any of those sort of details. They're just working for you.
Yeah, I think that's something that obviously, as a developer, not just .NET developers care about, right? So we just want to be able to build up and focus on building our apps, and having the database taking care of the hardest things, right?
Yeah, I think that a key aspect is that you have a complexity budget in your application. And if you choose a complex infrastructure, then you spend all of your complexity budget on that. And by the time that you have the opportunity to write actual business value, where there is no more time, there is no level for complexity. With RavenDB, I think that the aim is that the infrastructure should be just there. It should be boring, and you won't really even think about it. And all of your complexity budget can go into delivering the business value that you need. If we take the online shop as a good example, I'm going to now develop some workflows around so user can decide, you added this to the shopping cart, you probably want this, or stuff like that, whatever you actually need. Because you don't need to spend so much time at the database layer and doing all sorts of finicky stuff about how do I persist and how do I query the data back.
One of the things that lots of people like using relational databases, you already touch a little bit on that, is the transactional aspect, right? So they like the ability to structure the data and having the database providing guarantees on that.
Yes.
So you are saying RavenDB supports
Absolutely.
transactions, and that's something
I have a blog post that goes something like, "You will pry transactions out of my cold dead hands," because it does not make sense to have a database with no transactions. Now, at this point, I'm a database developer. I build databases for a living. I think that at this point, I'm at my 7th or 8th DB engine.
Wow.
And I had a chance of building transaction support, and I read through a lot of database code to see how they implement transactions. And it's non-trivial in the extreme. Now, even if you're talking about, I don't actually care about transactions, then that's wrong, because in tomorrow, you would have the need to make something a little bit more complex. And if you don't have transaction, then someone needs to ensure the consistent behavior of the system. And suddenly you have this hot potato of complexity lands in your lap, and you have to juggle it somehow. And the more you push it up in the stack, the more complex it becomes. And it's very easy to explain that. Try to imagine from browser API, you're trying to make send a Twitter message and I don't know, send a Twitter message when you click an order OK? How do you make sure that those two items happen in an consistent manner? Well, you can't. There are patterns on how to do them, outbox patterns and stuff like that, but they rely on you having transaction access somewhere else in order to handle that.
You want to solve, as a developer, you want to solve those problems, right? You want the problem to be already solved by the database layer.
Or your infrastructure. That's what it's there for.
Exactly. One of the interesting things about RavenDB is that I believe it's written in .NET. Am I right?
Yes.
And obviously, lots of people might have misconception about that. So about the performance of RavenDB, like it's a managed language, right? So how can you possibly make it, make it work in a performant way? So I'm very interested to know about your experience in building the database engine in .NET and what you've learned about it and what you can say about the performance of it.
I'm writing now a series of blog posts on implementing a Redis clone using C#. And the very first version I wrote, which I intentionally wrote in a naive manner, is 100 lines of code. It implements get set functionality, and it can process just under million requests per second.
Oh, wow.
This is .NET 6. This is naive code, which is important because it is utterly insane when you think about it. I have done nothing, and I'm getting to almost a million requests per second. I spent a few nights optimizing that. I can get to 2 million requests per second, and I have the benchmark to show it for them. So the interesting, when you think about databases and managed languages, well, the first thing to realize that there are actually quite a lot of databases written in managed languages. Hadoop, Cassandra, Zookeeper are all written in Java, which is a managed language. And I think that there's quite a lot of databases that are not written in a managed language. Most of the relational databases, for example. But I think that people are significantly underestimating the complexity that is involved there just for something that is trivial. For example, in my Redis clone implementation, I use a concurrent dictionary. I just used that. It was there, it was immediate, it was correct. And again, million requests per second. If you want to try to implement something like a concurrent dictionary in an unmanaged platform, well, now you have to deal with hazard pointers, epoch-based collection. There is something else that I don't know. There are like 3 or 4 different ways to do that. All of them amounts to basically implement your own GC, which you would probably do very, very poorly. And that's the only way to make something like that work. Now, if I'm going back to when I started writing RavenDB, I wrote it in C# because that was the only way I could actually manage that level of complexity. Because I could throw things on the GC, on the platform to handle later. I didn't need to be very careful about memory management because the GC was that quick to catch me. Now, eventually, when I talk about 5 years of developing RavenDB, the architecture became untenable. I couldn't make it work this way. So we sat down and re-architected the solution, and then we realized something really interesting. C# as a managed language has the following feature: struct as value type, pointers, direct memory access, and you don't need much more.
You have a lot of low-level stuff you can do in C#. Not many people realize that.
Yeah, and I'm talking, and just to be clear, I'm talking to you before we got span, before we got all of those sort of things. Years before, that was in 1.0. So we're talking about 2001, 2002 when it came out, it was there. And why it was there? Because it needed to integrate with Chrome and Windows, which were all unmanaged. So you have this perfectly amazing low-level infrastructure just there and waited for us. So we re-architected RavenDB. We took ownership on the memory. So instead of allocating everything to the GC, we allocate native memory and use that. But
okay.
it turns out that a lot of the complexity in native languages, if you don't have a GC, is how do you handle all of the myriad of edge cases that you have to deal with? If I'm trying to write to the disk and I fail, but halfway through, and then I'm trying to log that and I fail right into log because the disk is full, am I leaking memory? Probably. So, and you have to be extremely careful about how you manage all of those. With Raven, because we're running in .NET, we actually had the ability to say, hey, we're going to do manual memory management, but we're going to allow ourselves to be sloppy. We're going to allow ourselves to say, hey, if we miss out on freeing this memory, then this is the finalizer value, which will be picked up by the finalizer at some point and get released. So this gives you an incredibly robust system. It also means that you have a far better performance system because you can say, oh, I only need to deal with the complexity in the main part. And I have to say, in the 7 years since we started the re-architect, the RavenDB code looks very different than sorry, not the RavenDB code. The hotpaths in RavenDB looks very different than standard idiomatic C# code. But those are just the hotpaths. And RavenDB is about million lines of code, something like that. And there are a lot of places that you don't actually need that level of attention. So you can write idiomatic code. And it turns out that there's a lot of tricks that you can play with the JIT, for example. So C# has generics. You can specialize on generic types. So now you can basically emit code that, trivial and silly example. I have the need to scan a sorted list. And I have to do a range-based scan. Now the range may be exclusive or inclusive. So I don't know, when I'm writing the code, I don't know that. When I'm invoking the code, I do know that. So I wrote the code, so I actually have a class that has the behavior on the low value and the high value, and you can put an inclusive or exclusive value there. And those are just generic, and those are structs with the name inclusive or exclusive. Why does it matter? Because when I'm doing an inclusive search, the GC is going to specialize that code so it would avoid the checks, whatever we are greater than equal, and just stop at the right location. And just a thing that you can, and then the code reads nicely, but gets optimized to the writing. If I was working in C, for example, well, welcome to tons of macros and things like that. Another thing that I think is really important is the fact that C# has a lot of introspections. So I'm able to say, I'm going to define some convention about how I'm using my code, and then I'm going to apply that knowledge.
Yeah,
I know that this route goes to this location, and I don't need to. I can just write a code using the open close principle. So just add code and not modify code as well. And finally, I think that I want to give you an experience that I had. The year is 2001. Oren is sitting and writing his very first C# program. And it went something like that. Public class program, form1, static void main, form1.show. And I'm writing that. Remember, at the time, I was a C++ developer. I'm running that, and I'm getting an reference exception. And I could not understand what was going on. And okay, this is a beta, alpha, whatever. This system is crap. I'm leaving. I'm going back to C++. And maybe a week or two later, I realized that I had an issue. Because when I wrote form1 as a field in the class, in my head, I was creating the object. But the equivalent in C++ would be form1. So a pointer, a reference, not the actual value. So I wrote the exact same thing in C++, and I ran it. And I got a access violation at blah, blah, blah. And then I ran the same thing in C Sharp. And it says, now thanks exception at line X. And I could go to line X and see where exactly the problem was. And I remember sitting there and it was like being given a hug.
Yep.
Like, wow, you just made my life so much easier. So the capabilities like that, good errors, the ability to have a great debugger, the ability to very easily integrate with a multi-threading and concurrent queues, stuff like that, where the hard part of how do I know where to drop something and delete it is already handled for me by the GC. That made the decision of using C# within RavenDB obvious.
I definitely relate with that. I also at university had to build some C++ FTP server.
Oh, that's
access violation exceptions all the time. So yeah, when I met that, it was like love first sight to me. So yeah, definitely understand that. And one of the cool things about you is that over the past almost 20 years, you kind of blog about all of these things you've learned. You have probably more than 7,000 blogs on your platform. So you definitely documented all your journey there, all the things you've learned. No, that's quite amazing, Oren. So I'm quite impressed. So coming back to RavenDB from a commercial perspective, right? So if I'm convinced I want to use RavenDB, so who is using it right now? So what are the is it free? What do I need to pay? What are the differences between the commercial side of?
Okay. So RavenDB is a open source project. You can use it under the community license, and that is completely free. If you use it in commercial settings, you would typically purchase a license. The question is also how are you going to run it? You can run RavenDB on premise on anything from I have a Raspberry Pi here that runs RavenDB, and all the way to big cloud instances. So it's interesting because if you run RavenDB on your own platform, then there is a licensing fee. If you run in the cloud, then you can run it on RavenDB.cloud, where it's running the service, and you don't really need to consider deployment and everything around that. In terms of who is using that, we have Kobo Rakuten, Toyota, Particular, JetBrains. There's quite a lot of users. It's interesting because RavenDB is a database, so it's very hard to narrow down, we are being used in the real estate environment. We actually are. I don't know why. There's that in, at some point we got, we had a month where almost all of the customers were some sort of real estate and property management companies. In terms of how you get it, you go to RavenDB.net or RavenDB.cloud. There is a free download. We even offer a free instance in the cloud, so your own private private instance. There is also live-test.ravendb.net, and that is a public instance that you can work with and experiment with. Something that is probably important. RavenDB is meant to run in this distributed environment, and one of the things that we did in the design was run it in a multi-master setup, so you can have multiple nodes, all of them accepting writes. It turns out that this is an incredibly useful property for anyone who is writing geo-distributed software. For example, if I'm in a retail environment, then I might have Ravi running on all of the, how do you call it, where the clerk goes beep, beep, beep.
Checkout.
Checkout, yes, all of the checkout systems. Thank you. I had a total blackout for a moment. So on all of the checkout systems, and all of them are reporting to an instance in the backend, and all of the branches are then reporting to headquarters. And because RavenDB allows you to do writes on multiple locations at the same time, then it's very easy to handle scenarios such as, oh, I have a network disruption or something, so you can write connected systems that can also operate offline.
Wow. Cover a lot of scenarios, definitely.
Yeah.
Very interesting. All right, thank you so much. I believe then going to the website, basically, it's the best way to learn about RavenDB. I'm sure there will be all sorts of things to play with. If I am of course, RavenDB is written in .NET, right? So a lot of my people listening here are .NET developers. So I believe you said it's open source. So I guess people can contribute to it somehow.
Absolutely.
Are interested?
Yes.
How is that on GitHub, I believe?
GitHub.com/RavenDB/RavenDB. And we also have issue tracker there, and some of those issues are up for grabs. So anyone who wants to come in and help is more than welcome. I would caution you that the past few people who have done that, we end up hiring. Yeah. And it's interesting because in many cases people hear, oh, a database engine, and it's it's complex and whatnot. And some of the issues that we have is, oh, I need to integrate with Quartz.net, for example, standard.NET development all the way. So there is quite a lot of things that we'll be very happy if someone wants to come in and contribute.
Definitely interesting project with a lot of cool stuff. As a .NET developer, right? So thank you so much for all the information on RavenDB. It's quite interesting project. So at this point, I'm just want to switch a little bit topic in the sense of getting to, because you've been a .NET developer, quite successful. You're international speaker, I think pluralsight author, correct me if I'm wrong, like you're maximum MVP, CEO of a company, you've been contributor to open source for quite some time. So you definitely had an amazing career in around the net. So I have to ask the question, what kind of advice do you have for developers working in the net ecosystem at any stage of their career, like starting out to in the
Number one advice: read the error messages.
Read the error messages.
Read the error message, all of them, even the internal, even the inner exception. Look at the stack trace. And I spoke earlier about the null reference and the line number, etc. I have people who come and says, "Oh, there is an error."
I know what you're talking about.
Okay, what's the error? Oh, there is a network error. what is the specific error? What's the stack trace? Give me, and sometimes I have to like 3 or 4 rounds of questions. And in some cases, I can look at the full stack and say, oh, this is, I can see where it's happening. I can see what happened. I know what the problem is. So first of all, read the error message completely and try to speculate what it can happen, what it can be, what happened, how, what's the scenario. Another thing is read source code, not just your own. And I think that's one of the things that we typically do in interviews. So just general information. One of the things that I found out is that because RavenDB is outside of the typical niches for C# developers, I don't get a lot of benefit from getting people with a lot of experience. So most of our hiring are at the junior level. And one of the things that I do, I give them a piece of code to read. And this is maybe 50, 70 lines of code. And I ask them to tell me what it does. And the number of people who would read out to me every single line is amazing. And that's almost always, at this point, I know that if you're reading me the code, you literally reading what's going on, instead of telling me, oh, this method does X, instead of, oh, this is a method that accepts 2 integers, something like that. I already know that you don't have the Kali doesn't have the ability to abstract the thing, or don't have the experience to look beyond that line of code. Something that I really enjoy is going into foreign code bases and reading them. And in many cases, I would read them in an arbitrary order, lexical order of the files in the system, which is not how you typically approach it. And I do that because I found it fascinating to look at a piece of code and speculate about what it's going to do. And then I complete the reading and understand what it did. And it's like being an archaeologist. It's like playing a mystery game or something like that. It's really helped to understand how things are happening, what's going on.
Yeah, that's great advice for sure. It's something I need to do more. Absolutely.
And if you go and read open source projects that are being actively used, you will find a lot of amazing tricks. For example, if you go and look at the code of Titosoft JSON, he's doing a lot of reflection there, a lot of caching. And okay, I can see how that works. You can see how a parser is being built. And a JSON parser is quite fascinating to read because it's such a small grammar. If you go and look into how there is a NuGet package that handle retries, poly something, I don't recall, I can't recall the name, but if you go look at that, poly, okay. So, here all of the interesting error strategies. And in some cases, it has 0 impact on your life. But there are many cases where the fact that you know, oh, here's how you do this, here you do that, also give you such such a level. To give you a few years ago, almost 15 years ago, I was working in a company where they had a tree view that represented the internal structure of the company. One of the customers was an army, and they could not use the system because the tree view would be populated with everyone in the army, so a few 100,000 people. And every click that you had on the tree view would have to figure out, do you have access to see this? So try to imagine that you're going, you're opening the,
huge amount of data.
no, it's more than that. You open the, it was ridiculous. You open the, let's say that you have the army at the top, the previous groups. You click plus to open that. And then it's scanned through all of the units in the army. It does that in a recursive manner because sometimes you have access to a nested value, not to the top value. For each one of those, you'd have to check if you have access. It gets audited. And you wait 40, 50 seconds for the things to operate. I change things. So, okay, let's load the structure of the company, this is the army, into memory and map the access size that you have. So the entire thing was in memory, basically what is concurrent queue, concurrent dictionary, sorry. And I was still scanning, but now I prepare all of the data in advance. So instead of 40, 50 seconds, it was 5 milliseconds. And it was usable and working. And that was just because I did not try to solve the problem. Because the problem was, oh, I'm generating tons of queries to the database. I was actually able to look at that from a completely different perspective. And I think that if you go and read code, especially if you go read a multiple version of the same thing. So for example, I used to work a lot on a project called RhinoMox, and that use a library called Castle Dynamic Proxy. And that was actually that is actually using dynamic IL generation to subclass your objects at runtime. It is an amazingly beautiful technology. Along the way, because I was involved in that project, I had to go very deeply into how generic implemented in C#. I learned that I can do dynamic code generation. And at some point I had to do something dynamic, and the cost of doing that was high. So I had to set a property, I think. And I didn't know what the property name was upfront, but after that, I would always know that. So I said, oh, well, I can just generate the code to set that property on the fly. And then I don't pay any of the additional cost around that. And that's just from messing about in things.
Absolutely. So it looks to me that is, look at your error messages, leverage the amazing tooling that we have in the ecosystem. Read other people code and try to understand the patterns that you can reuse going forward as well, and try to build stuff yourself, right?
I think that all of that ends up being, you need to have the ability to build a mental model of how the software works. If you think about, let's take a profiler as a good example. I'm looking at, I want to optimize my performance. So I'm looking at the number of calls and the amount of time that it's spent in each function. And in some cases, just those two values can tell me, oh, I'm doing something strange here. But in order to be able to tell that, I need to have a mental model of what is supposed to happen. Another thing that I think is incredibly valuable is you mentioned other tools, but learn to debug, learn to understand what's going on. The C# debugger, the Visual Studio debugger, the Rider debugger, the VS Code debugger are wow tools compared to what you generally have from other environments. And it matters because they can save you a lot of time. At the same time, the dotted environment have a lot of tools like counters and stack trace and memory management and all sorts of things that you can go into a live system and pull all of that information out of that.
And then you look into that and you go, wow, combine that with the ability to have a mental model of what's going on, and you can typically, in a very non-invasive manner, figure out what's going on. And beyond anything, those are the kind of skills that transcend the particular project that you work on. It would even transcend the particular technology. So if you're a .NET developer and you're very familiar with how the GC work and how the JIT work and things like that, and now you end up writing Python code for a while, well, there are similar tools and capabilities there, and you can make use of them, but the hurdle of understanding what you need to do is already gone. And that is amazingly important aspect.
Yep, totally agree on that. Absolutely. Awesome. Thank you very much for all your advices, Oren. I guess the final question is basically, how can people, follow you? How can people stay in touch and learn from you?
RSS through Ayende.com. I know this is old school, but I found that the ability to give complex thought does not work very well on social media, especially on social media that is subject to character limits. I'm also on Twitter at Ayende, which counters what you just said. But my blog, I think, is the best resource.
Fantastic. Thank you very much for your time. I really appreciated it, and stay in touch.
Okay, absolutely.
Bye.